Are there any questions? All right, then let's talk about test 1A. Those who have not had me before, I can't remember which group I mentioned this to or not. Test 1A, there's test 1, there we go, the stack is conform. There's test 1A and test 1B. These are not two parts of one test. These are two separate tests. It's just originally, my test 1 covered all the material through what in this textbook would be chapter 21. It was 18 through 21, and then I broke it up into two pieces. So if you're looking at old tests and you see test 1, that'll cover the material that's on the first test and the material in the second test. Test 1A would cover just the material in the first test. It is currently scheduled for Thursday of next week, 1 week from today. The chapter 19 master set is due on Tuesday. We can keep it like that, get it out of the way. I will have less time to get you feedback on chapter 19 master set. Or we could push the test off till the following Tuesday, I guess. Or we could push the test off to the following Tuesday. Any opinions?
I would say push it.
I like Thursday, but I'm good either way.
And everyone else is just flexible, whatever.
I'm good with pushing it as well, to get some more time to get feedback and study.
I think obviously the extension would be nice for anyone.
The disadvantage is that we'll be covering material that's on test 2 or test 1B before we've had test 1A. And I did have a situation one semester with the 252 group where I finished the material for the second test before they had taken the first test. That was one semester. All right, let's just push the test off till the following Tuesday, so a week and a half. If you're just being an incredible introvert and really it's gonna mess you up to do that, talk to me individually and we'll come to some arrangement.
Just don't tell Alicia. It'll be a surprise.
If someone could remember to tell Alicia in case I forget, tell her. All right, I do want to comment about the lab that we're going to be doing today. Last time we talked about the fact that if I got a positive and negative charge here, my electric field lines would go from the positive to the negative. It's like I've got a fountain of water and a drain. So ideally, it's gonna look something like that when I look at the electric field. Now we can find the exact values, or we can find the direction of the electric field at some particular point. So at this point right here, my net electric field should be tangent to my curve. And the way we would find that is I know I have an electric field coming from the positive charge going in that direction. I have an electric field heading towards the negative charge. The negative charge should be a longer arrow, if I represented it properly, because it is closer to the negative charge, therefore a stronger magnitude of, actually let's use the wording of a stronger electric field strength, or a larger electric field strength, either way. So if I add the two vectors together, I get, well, I guess if I did it properly, thank you, Sean. that the resultant would be an arrow pointing that direction, which gives an idea of how strong the electric field is, as well as the proper direction. Now, measuring the electric field directly is not particularly easy, and we are not gonna find it directly. What we're gonna do is find equipotential lines. So, we talked before about the potential. I guess on Tuesday, we talked about the potential. So if I have a positive charge, I know the potential is equal to the electrostatic constant, Q over R, plus some constant. And if I got a negative charge, we'll just do positive charge. So if I get a positive charge here, I know if I'm the same distance away from that positive charge, every point on this dotted line, assuming R is the same, should have the exact same potential. So this is an equipotential line. Equipotential, however. Equipotential line. So it's every place that has the same electric potential. Now what we're going to do here is we're going to find a whole bunch of places that have the same potential difference. We're going to follow the directions, but I believe we'll have a probe here heading to a multimeter. And we'll find the potential difference between the negative charge and some point here, or between that and the positive charge. Again, follow the directions. And we'll find some potential here. Actually, we'll find a potential in the middle, and then we'll try to find other points that match that same potential. And what you'll end up with, ideally, you'll have a negative charge here, a positive charge here, or vice versa. You find the potential at some point, you find other points which have the same potential. And it's not necessarily a connect the dot exercise. If everything works beautifully, this will be a nice curve like this. And there's a picture on page 1, I believe it is, of the lab, which shows what ideally it looks like. However, yours probably won't, because it's a physics lab. What you might end up with, every time I do this, I keep thinking that's probably the positive and that's the negative. But you still find the potential, you drew the lines. I know ideally it's a nice smooth curve like that, but reality is I might get a point here, might get a point here, might get a point there, something like that. You really aren't going to be looking at a smooth curve there, but feel free to smooth it out. It is not a connect the dot exercise. What I'm doing right now is not what you should be doing. Try to go for the curve that best fits the points, and you can eyeball it. Now sometimes you end up with these really strange configurations. So if I went for that as my smooth curve, we'll just leave it like that for right now. Let's assume we got one like this and another one that kind of looks like that. When I draw my electric field lines, I know an electric field goes from positive to negative. The electric field line also crosses the equipotential line at a right angle. So if I just draw, well, I know the electric field goes from positive to negative, it's going to look like that. I'm going to look at that and go, well, actually it kind of works there. Let's do the other side. That kind of works there too. There we go. I'm going to look at that and say, that's not a right angle. And when I grade this part with, you're drawing the electric field lines, I am going to basically do a spot check. I look and I say, is that a right angle? Yeah, that's a right angle. And I hit a couple points, and if they're all right angles, it's fine. And if they're not, then I start circling them and taking points off. So what you would do in a situation like this, you aren't going to end up with a nice smooth electric field line. You're going to end up with, let's see, I know it has to cross at a right angle there. It's got to eventually hit over here, so I've got my equipotential line there, across at a right angle on this side. Something like that. Or over here, I know it has to cross at a right angle. That's at a right angle. That's a right angle. So your electric field lines might look a little wonky depending on how you draw your equipotential lines. Then, in their instructions on how to do it, you each take a different point, figure out what the direction of the electric field is at that particular point, because the electric field should be should be tangent to your electric field line. So your electric field at this point should be in that direction. You can take a protractor, measure the angle, or do some trig because it's a gridded piece of paper. And then you'll calculate what that angle actually is, or ideally what that angle is, and then compare the two. I do make, you know what, I'll leave that without comment. Any questions right now?
If we're just really bad at drawing right angles, is there anything we could, you know, denote that's at a right angle, or do we just have to be very careful?
I would say be very careful. One thing that helps me personally is if I'm trying to draw a right angle at this spot right here, if I can just sort of ignore all of that, the better. So covering that up helps me draw a right angle better, because otherwise I'm influenced by that stuff. Other questions? All right, let's head down to the other room. It is open and waiting for business.